Today's recording comes from Pre-Algebra, Chapter 4, Lesson 1, and if you give me a second, I'll get you guys a quote. Okay, quote comes from, as always, Lemony Snicket, Horseradish, Bitter Truths You Can't Avoid, page 137. Fate is like a strange, unpopular restaurant filled with odd waiters who bring you things you never asked for and don't always like. So true. Okay, so let's talk about divisibility and factor rules. One number is divisible by another if the remainder is 0 when dividing. So I could say 12 is divisible by 4 because when I divide 12 by 4, I get 3 with no remainder. All right, so there you go. All right, so there's just an example. Okay, erase. All right, so let's talk about the divisibility rules for 2, 5, and 10. A number is divisible by 2 if it ends in 0, 2, 4, 6, or 8. So you don't even have to, well, you still might have to do some, division, but you can tell if a number will divide by 2 cleanly, without a remainder, if it ends in 0, 2, 4, 6, or 8. And the same thing goes for 5. If you need to divide a number by 5, if that number ends in 0 or 5, it will divide without a remainder. And then with 10, if the number ends in a 0. So let's go ahead and look at these examples. 160 should be divisible by 2 because it ends in a 0, and it should be divisible by 5 because it ends in a 0, and it should be divisible by 10 because it ends in a 0. Check that out. All right. 56. 56 is divisible by 2, and that is it because it ends in a 6, which means it is not divisible by 5 or 10. 53 is not divisible by any, so that would be a none. And 118 is divisible by 2 because it ends in an 8. All right, next set of rules for 3 and 9. This one's a little tricky. Now, for 3 and 9, it matters if you can add up the numbers and that number is divisible by 3 or 9. So let's go ahead and add up some digits. So a number is divisible by 3 if the sum of its digits is divisible by 3. So here's my example. If I have 6 plus 4, well, that's 10. Is 10 divisible by 3? Nope. And it is also not divisible by 9. So 64 is not divisible by 9 or 3. 63, on the other hand, is because 6 plus 3 equals 9, which is divisible by both 3 and 9. Okay, so what about 473? 7 plus 3 is 10, plus 4 is 14. 14 is not divisible by 3 or 9, so that one doesn't work. All right, 174. 1 plus 7 is 8. 8 plus 4 is 12. Well, is 12 divisible by 3? Yes, it is. So it is divisible by 3, but it is not divisible by 9. Okay, what about 43,542? Well, we got to add them up. So that's 7 plus 5 plus 6, because I added weirdly, and I'm still not done yet. 7 plus 6 is 13. 13 plus 5 is 18. Well, 18 is divisible by 3, because 3 times 6 is 18, and it's also divisible by 9. So that's one of the situations where it's divisible by both. Though normally if it is divisible by 9, it will also be divisible by 3, but not vice versa, okay? Just because it's divisible by 3 does not mean it's divisible by 9, especially for the smaller numbers. Okay, next page. A number is divisible by 4 if the last 2 digits are divisible by 4. So is 0 divisible by 4? Well, yes it is. 100 is divided by 4 is 15. All right, is 16 divided by 4 divisible by 4? Why, yes it is. 16 divided by 4 is 4. And what about 64? Yeah, it is. So this one is also divisible by 4. So do you guys get what I mean by the last 2 digits? So this really only works for 3-digit numbers or higher. But if you have a 2-digit number, like 64 or 24 or, some of the other ones, it's really easy to see. But you kind of just need to know your multiplication facts for 4. For divisibility rules for 6, it has to be divisible by both 3 and 4. It can't be one or the other. It has to be divisible by 3 or 4. So for 12, if we're going to add it up, 1 plus 2 is 3. So 3 is divisible by 3. So it's also divisible by 3. And the last 2 digits, well, you just need to know that 12 is divisible by 4 because 3 times 4 is 12. Okay, and then for this one, you just need to know the facts, though. 2 plus 4 is 6. Is 6 divisible by 3? Why, yes it is. That means 24 is divisible by 3. And you just need to know that 4 times 6 is 24. So 24 is also divisible by 3. But here's a big one. Well, the last 4 digits need to be divisible by 4 to make the whole number divisible by 4. So since 12 is divisible by 4, this number is divisible by 4. And then since we need to add up, 6 plus 1 is 7, 7 plus 2 is 9, 9 is divisible by 3, therefore it is also divisible by 3. Okay? So, yeah, so like a number that's only divisible by 4 but not by 3 would be like 200. Therefore, 200 is not divisible by 6. Because it has to be divisible by 3 and 4 to be divisible by 6. All right. Divisible by 8, well, if the first 8 or the first 3 digits are divisible by 8, then it works. Unfortunately, 8 is one of the worst divisibility rules there are. It's one of the craziest. Is 400 divisible by 8? Well, yeah, it is. And 1,800 is, yeah, because 800 is divisible by the last 3 digits, right? 800 is divisible by 8 100 times. Therefore, 1,800 is also divisible by 8, okay? This is a crazy one. You just kind of got to know it. I don't think they ask you any questions like this on your homework, so you don't really have to worry about 8, but know that there is a divisibility rule for 8. All right, last slide. Listing positive factors. We got to write all of the ways you can multiply 2 numbers together to get the said number. So let's go ahead and talk about all the different ways that I can get 10. Well, I can do 1 times 10. I can do 2 times 5. And that's it. So the positive factors for 10 are 1, 2, 5, and 10. Okay, 24, well, I can do 1 times 24. I can do 2 times 12. I can do 4 times 6. And can I do anything times 3? I don't think so. So it's 1, 2, 4, 6, 12, 24. Those are the positive factors of the integer. 31, there is nothing times 31. I know that for a fact because it's prime. Prime means it's the only thing that you can get multiplying together to get 31 is 1 and 31 in itself. So 1 and 31 are the only prime factors. All right, that is it. Have a good day. Bye, everybody.